Thousands of years ago, scribes pressed wedges into clay to record humanity's first written words. Today, hundreds of thousands of these tablets sit untranscribed, waiting. This is NabuOCR, an end-to-end vision model that reads cuneiform directly from images. Named after Nabu, the Mesopotamian god of writing, it bridges ancient script and modern AI. Cuneiform OCR is hard. The script is non-Latin, tablets are heavily worn, images show multiple faces at once, and glyph shapes vary wildly across periods. Existing tools use multi-stage pipelines that accumulate errors. NabuOCR takes a different approach. One model, image in, transcription out. I built the dataset from the Cuneiform Digital Library Initiative. Starting from 135,000 transliterations, aggressive filtering removed damaged tablets, missing images, and low-quality photos, leaving 33,000 clean examples for training. The base model is PaddleOCR VL. Since its tokenizer doesn't include most cuneiform, I expanded the vocabulary with all unique signs from the dataset, plus face markers like obverse and reverse. Using unsloth for efficient full parameter supervised fine-tuning, I trained for 2 epochs. Loss dropped very sharply in the beginning, and then gradually refined over the remaining steps. Supervised learning got the basics, but the model still made systemic errors. I applied group relative policy optimization to refine it further. The model generates multiple transcriptions per image, scores them with reward functions, and learns to favor better outputs. It took many training runs to find the right approach. The key insight was building a visual similarity matrix. I rendered every cuneiform token, then computed how much their shapes overlap. This lets the reward function give partial credit when the model confuses 2 signs that genuinely look alike. This creates denser gradients. When all transcriptions get a token wrong, the reward can still guide it towards the one that was the least wrong. I also added reward annealing, a form of curriculum learning. Early in training, the model gets more partial credit for these near misses. As training progresses, the reward becomes stricter, pushing towards exact accuracy. Here's the full picture. Token error rate measures edit distance, so lower is better and 0 is perfect. The base model scored 100%. It had no concept of cuneiform, essentially giving random output or task refusals. After supervised fine-tuning, median token error rate dropped to 60%, a 40 percentage point improvement. The model learned to produce cuneiform and understood tablet structure. GRPO brought a modest improvement to the median, but that's not the whole story. The worst case predictions improved dramatically. 98th percentile dropped from 94% to 75%. Variation between responses was cut in half. And the errors it does make are now visually closer to correct, confusing signs that actually look alike, not random mistakes. Each stage built on the last. Base knowledge, then task learning, then refinement. Let's see it in action. Here's a well-preserved tablet. The model correctly identifies face markers and transcribes the cuneiform sign. This tablet is more worn. You can see the model handles the degradation reasonably, though some ambiguous signs cause errors. And here's a multi-view image with obverse, reverse, and edges. NabuOCR processes all faces in a single pass. With thousands of tablets waiting to be read, NabuOCR gives Assyriologists a head start on every single one. Model and code can be found in the description. Thank you.